Alright, welcome back to Mr. P Helps with Algebra 2. This is Unit 1, Topic 3, SLT24. We're going to start off with, this is a question I had similar done to one in a prior video. So we're starting off with, this is an exponential function. And the reason I know this is exponential is because it has a horizontal asymptote. Because it has this line which is never going to reach, which is at 0. So that's y equals 0. The domain of this function is going left and right infinitely, and the range is everything above 0. The entire function is above 0. That's the reason why it's an asymptote. It's increasing the entire time, so x can be anything, and then it will always be increasing at that time, and it's never decreasing. What equation would model the growth of f of x, and what would be its inverse? Okay, so we know anything to the 0th power is 1, so it has an asymptote of 0. So in this case, we have y equals b to the x powered, and then usually we have like this up and down transformation, which is our asymptote, which in this case is 0. And a lot of times we would have our up and down number right here, which is our y-intercept, which is right here. But that in this case is 1. So this is 1 times a rate of, well, the next number is 5, so it's 1 times 5 to the power of x. And there is no asymptote, there is no transformation up or down, so therefore the asymptote stays at 0. Alright, so in this lesson we're going to be doing average rate of change. This is lesson 24. Average rate of change we've done with linear functions, with other functions, but today we're doing it with logarithmic versus exponential functions. Identify the functions above as exponential or logarithmic. Now, graph 1 has a horizontal asymptote, as you can see right here. That's an exponential function. It's curving up. Whereas graph 2 has a vertical asymptote, so therefore it's logarithmic. Are the functions increasing or decreasing? They are both increasing, so this one's increasing, this one's going up as well. Can you determine what interval over which the functions are changing about the same rate? Well, you can, and this is kind of what this lesson is all about. So the time when they're going about the same rate is during like this time. Okay, that was actually poorly done. So let's try that again. So about this time right here. During this time, they are parallel to each other. I know I'm kind of messing that up. I actually should have shortened that length a little bit. And these two lines are parallel. So over that time from between 0 and maybe 2 or 3 for the first 2 seconds. All right, at the world, graph the world's population as a function of the time below. Estimate the average rate of change from 2000 to when x is between 2000 and 2100. So it's at 2000 right here, and it's at 21,000 right here. So it's at 2000, so this is 2000 comma, let's say it's about 5.2 billion. So right here exactly, I wish it was exactly 5, so that's about 5, 6, 7, 8, 9, 10. Okay, so it's going by ones. Okay, so that makes it easy. So let's just say that's about 6. And over here, it's at 2100, comma, this is at about 20, 21, 22, 23, so about 23. So we've done this before, so how do you find average rate of change from here to here? So we're looking at a linear pattern, so we're going to use the formula y2 minus y1 over x2 minus x1. All right, so second y minus first y, so that's 23 minus 6 over 2100 minus 2000. Okay, so 23 minus 6 gives us, what was that, 17? So 17 over 100, which is about 17 hundredths of a billion. So 17 hundredths of a billion per year is, it looks like, what it comes out to be. So what is that, about 170 million per year. Estimated interval spanning approximately 50 years that has the equivalent rate of change. Now this line right here is a timeline, and you already see the answer. That's from the year 2020 to give or take about the year 2070. That's a 50-year span. And the reason why I know it's increasing about the same rate is because it's parallel to this line here. So it's increasing at the same rate. So its slope of that linear line is about the exact same. So what is the average rate of change in Celsius per second at time interval of 15 to 165? So here's 15. So that's 15 comma 75, and here it looks to be about 120, what is that, 50, 60, 175, no, 170, sorry, 160. I can't read the numbers, sorry. So that's going by 15s. Okay, so this is 155, so that's 150, that's 165, comma, 10. All right, so that's 75, y2 minus y1, 75 minus 10 over 15 minus 165. 75 minus 10 gives us 65, 65 over negative 15 minus 165 is 150, and then you could just simply divide 65 divided by negative 150 and use your calculator, which I do not have one handy on me right now, but that would give you your average rate of change. Estimate the interval spanning approximately 90 seconds, so that's equivalent range. Okay, so 90 seconds. So here's from 30 seconds to 120. So this is parallel to the original, so it's decreasing at the same rate. Now, it's not decreasing at the same rate here at the beginning. What I'm saying is over that time span, it's equivalent to the amount of decrease over that same time frame, over a different time frame, sorry. So it's decreasing less than this one did, but it's doing it over less time frame. So that's the reason why it's parallel. So you can see all of these lines are all exactly the same. Estimate the average rate change from 2 to 16. So 2 is 2,000. Okay, this is nice and clean. Perfect. And 16 is, what is that, 38,000. All right, so that's y2 minus y1, so 38,000 minus 2,000. Which is going to give us 36,000 over 16 minus 2. 16 minus 2 is 14. So 36,000 divided by 14 is your average rate of change per year. Since 1990. So I'm going to assume that's going to be about 2.7, 2.5, give or take, about 2,500 per year. Over approximately 10-year span, so 10-year span, so we're looking for which one of these lines goes over a 10-year span. So to go from 6 to 15 is actually a 9-year span. If I go to the next one, that goes from 5 to about 15. So there we go. It's this line right here. So just keep making parallel lines until you find the one that's going at about a 10-year span. All right, so on which 4-year interval is the average rate of change at 8,000 per year? So 8,000 per year. So we're looking for a 4-year span. So if I start here, 1, 2, 3, 4. How much did that increase? That increased way more than 8,000. So I'd need to step it back a little bit. So find another one until I find an answer that works. So 4,000, 4,000 would be 8,000. That's way too much. So we're looking for a span. Actually, no, I need to step it up forward. So if I'm looking maybe 4-year span, that's going up not that much. Sorry. So I need to step back. So if I go backwards, and I wish I could clear this out, but I can't. So 4-year span, so let's say 2,000 plus 4 would be 6,000. So we're looking for probably something around here. So like here, 1, 2, 3, 4. That's probably not increasing enough. That's only increasing 2,000. So maybe something around here, 1, 2, 3, 4. That's pretty good answer right there. In fact, that's probably the answer right there. So that's a 4-year span. That's give or take about 4,000. It's going from almost 3,000 up to 6,000. Well, 2,000 something. Okay, so it's close enough. All right, which function do you see as the greatest rate of change for the interval of 0 to 1? So we're only going from here to here. The one that's increasing the most is the one that's going up the fastest, and that would be this dotted line's increasing the fastest. All right, homework. So I think I've actually already gone over all these answers on a prior video, but that's all right. This has an asymptote of x equals 0. The domain would be anything that's greater than 0, because everything to the right of this. Range is all real numbers because it goes up and down infinitely. Matter of fact, all of these will, because they're all logarithmic functions. They all have vertical asymptotes. This one's increasing the entire time, so x can be anything, which is all real numbers. And this one is never decreasing. So the same goes for all the other ones. This has an asymptote of x equals 0. This one is x equals 0. This one is x equals 3. And then a lot of the information you're going to see is exactly the same. All right, thanks again for watching. Please give it a like to help you learn something about logarithmic functions and finding average rates of change over time. Thanks again for watching. Have a good one.